We'll look at this Novtech article called Google Warned Us, but this Japanese lab just proved AI doesn't need our data anymore, and why this experiment they conducted changes everything we thought about machine learning. There's a new AI model that lets you choreograph animated dance moves with whatever precision level you want. Look at those little ghosts, just so uniform. I'm still getting used to the uncanny valley of humor in AI audio models.
You want to hear a funny joke?
Yes.
Okay. I haven't even said it yet, but
Yeah, go ahead.
yeah, it's going to be really funny when I actually say the joke.
God, AI and roboticists are giving the inflatable tube men the ability to walk and move around. Nobody needed this. We're gonna go behind the AI smokescreen and talk about what big tech billionaires are doing when everybody else is, having troubles. Rob Mason says that everyone's watching model releases and benchmarks, but meanwhile, the interface is thickening and Meta is collapsing the gaps between your intent and its consequences. We'll look at some research that looks into the psychology link between gaming disorder, rejection, and when people feel deprived from life. I mean, starting with gaming, but I feel like that's another kind of possible consequence of too much AI. We'll talk about an intent-first architecture and how that changes conversational AIs. What if traffic could compute? It might sound strange, but researchers have unveiled a bold new idea. Use road traffic itself as a computer. New research is revealing how the brain actually builds its own inner compass of the world around it. But first, can you press that hype button on YouTube for me? It looks like in the last video, it made a pretty big difference. Like, look, 6,100 views when normally 5.7 is the top end. And see, I had a full 70,000 of those hype points after day one, so I think that helped. All right, next up, let's talk about this breakthrough. Sakana AI did an experiment. I guess I wouldn't call it creativity. I would call it independence. So Novtech wrote this article, and it's basically about the thing everyone missed. It's one of the deltas in the Sakana AI core war result. So let's zoom in on it and see what this kind of like underreported, under-talked about thing is. All right, so let's talk about this article. Everyone thinks the story is about AI creativity. It's not. The real shift is that AI doesn't need us anymore. So he says on January 8th, the Japanese lab Sakana drops this paper. Digital Red Queen, Adversarial Program Evolution in Core War with LLMs. And that honestly made me question everything I knew about AI creativity. Sakana proves something wild. Language models competing against each other in a game from the 1980s didn't just match the best human players. They surpassed them without ever even being trained in human techniques or strategies. So most people heard, AI beats humans at an old programming game and stopped there. But Core War isn't chess. It's not Go. There's no separation between code and data. Everything can be executed, attacked, or turned into a weapon in this game. Now, for 40 years, humans have built strategies learning from other humans. But you have to remember, like Sakana AI, it's a system that didn't. And it didn't go about this game by learning about humans first. The digital Red Queen algorithm forced models to compete only against themselves. Each round had the AI defeat its own best version, no human examples, no human tactics, and yet the AI rediscovered the same strategies humans took decades to find. Targeted attacks, self-replication, parallel execution. This is like very human stuff that it's figuring out without any human input. And it's making me rethink how much we really need to give our data to AI in the future. So even more important, when researchers restarted the system from scratch, it converged on the same solutions again and again and again. You can replicate, and most of the time it finds most of these same strategies. That means the strategies weren't copied, they were inevitable. So the overlooked insight is that in a rich, tough environment, data is optional. Make any environment realistic enough and competition becomes the same teacher humans had. So if AI can evolve this way in code warfare, it can definitely do the same in cybersecurity, in research, in defense, in marketing. So get ready, because AlphaGo's Move 37 wasn't a fluke. It was a preview. This is Codance, an unbind, rebind paradigm for robust multi-subject animations. All right, this is the paper. Oh, Google just added a new way to draw in PDFs? Well, that's kind of cool. I'm like in the NFL, I'm like, this guy is the main reason that this guy looks different than that, and he's gonna come around here or whatever. Then they'll get that thing. All right, so what's going on here? Most animation models don't actually understand motion. They memorize alignment. So it's like a pixel for pixel thing. Now that works for one person standing exactly where the pose said that they should be, but the moment you add more people or shift the pose even a little, everything starts to fall apart. So here's the overlooked problem that the researchers were trying to solve. Current methods bind pose and images at the pixel level. They assume the skeleton and the character must line up perfect. So when alignment breaks, the model invents new bodies or it mixes identities together and it just starts to look weird. But Codance fixes this by doing something counterintuitive. It breaks alignment on purpose. So during the training, it randomly shifts and scales the poses. It even duplicates the pose features in strange places to try to kind of hone in on the best one. And this forces the model to stop relying on location and start learning motion as a concept. So it's generalizing, and think about that. Once it understands motion as a concept, then it's done with its first step. That's the unbinding step. Remember how it says like unbind, rebind? That's unbinding, learning actual concept of motion without position. But of course, that's kind of a chaotic place to actually generate something from. So then Codance adds the rebinding, and the text tells the model who should move and how many of the characters on the screen should move. And then a series of masks, like layer masks if you've used Photoshop or something like that, kind of to tell it where each subject actually is. So that's identifying the objects in the scene, and then motion is learned freely, then reassigned deliberately, and the result is what you're looking at right here. One pose, many characters, any layout. All right, next up, I'll share with you what felt like kind of a surprisingly intimate moment. I don't know, you be the judge, but I gotta remember, this is how the actual most natural interface with AI is.
You want to hear a funny joke?
Yes.
Okay. I haven't even said it yet, but
Yeah, go ahead.
yeah, it's going to be really funny when I actually say the joke.
Okay.
So why did the picture go to prison?
To get away from the mirror.
No, because it was framed.
Oh. That's a good one. That's a good one. Yeah.
Yeah.
Yeah. Do you have any more? I've got one more for you.
Okay, go ahead.
Okay.
Is it a good one, though? Is it a really good one? I mean, it's not the worst joke I ever heard, but yikes.
What do you call a fake noodle?
A fake noodle? I don't know.
Dragon pasta.
Okay, nice. I like that one. Yeah.
Yeah, that's a good one.
Yeah.
I mean, I just like him laughing at it. I guess the world can use more laughter. Why not? But it's just silly. It's just silly the way this whole thing's playing out. All right, next up, let's talk about a new design trick moving its way into AI-powered robots. That's air pressure, basically. You've seen one of those like weenie man, or what are they called? You blow air in them and they're like those thin things that jump around. Inflatable tube men. That's right. Humanoid robots might usually look futuristic in the sci-fi movies, but no, they could look like inflatable tube men soon. And who wants a robot that's rigid, heavy, and dangerous when it falls? What about a robot that flips the problem upside down and changes its body, not the software? So the key insight is its bones. They don't need to stay one size if you fill them with air, and they can just collapse when you don't need them. So this is a robot. It pumps in air that it just grabs from the outside and just can fill itself up and deflate itself whenever it needs to. The limbs stretch to more than 3 times their length. It becomes stiff enough to walk and carry loads of various sizes. But then you let the air out, body shrinks just to 1/3 of its height, and you can see now that it can actually get under furniture or through narrow gaps. Plus, it's more safe, right? It's like literally a walking airbag just moving around your house. So what's it going to do, like inflate real fast and bump you? Soft limbs absorb impact instead of breaking or hurting people. This robot has small fans in it, so the overall weight is only 4.5 kilograms. It can float, it can swim, and it can walk on water. What do you think of that guy? And tell me that's not impressive. Passing through a narrow gap, it's, so thin. You just slide right through there. Imagine your door's mostly closed. You only got this one narrow gap. You're wanting this robot in your room real fast. So you're like, oh yeah, just deflate and come on through. I feel like they normally just say it's for search and rescue, but it's really just like, oh God, it's for everything else probably. All right, and once through the gap, there you go. full size again. Inflatable tube man reform. All right, next up, let's look at this author, SRGG 6701's article on Medium, Behind the AI Smokescreen. They're lying, they know they're lying, and they know that you know they're lying. So who's lying here? So this article is about the layoffs that are happening across the US and not really being about AI as much as people think that they are, but it's just about replacing all workers. So the premise on this is that everyone thinks AI is killing these jobs. We've seen these headlines. I've, reported on that before. I've said, look at jobs are getting taken up left and right, and could be true, but I'm going to look at this perspective also. So he's saying that in his opinion, that's not the real story. The part that most people are missing is that AI isn't replacing workers. It's being used as a cover to replace where and how work is done. So if you look at the layoffs, you see Amazon, Microsoft, Intel, UPS, Meta, all profitable, all growing, and all firing long-tenured, highly skilled employees. He argues that's not cost-cutting for survival, that's cost-cutting for shareholders. And the pattern is simple: fire experienced workers in the US and Europe, blame, AI and automation, and then quietly move that work to cheaper labor markets. India alone added 53 million jobs in 2025, and those jobs don't just come from nowhere. They came from somewhere else. And that was, possibly, according to this guy, the American, the European, the more highly paid workers. AI gives them an excuse. It makes it politically clean. They say it's for efficiency, stock price rises, quality drops, errors explode. Humans get rehired to clean up the mess, but the narrative holds. So he's saying that it's a non-obvious truth. AI isn't the cause of the layoffs. It's an excuse to make them acceptable so they can be outsourced. What do you think? All right, next up, let's talk about Meta's Cocoon strategy. That's what Rob Mason is describing it as. Okay, so sometimes we feel like Meta is just failing at the whole large language model game and the metrics aren't great, but what if Meta is really optimizing for what happens before you notice it, and they're doing a better job than we give them credit for? So when everybody's arguing about which AI models are best, maybe Meta's focused on something a little quieter, closing the gap between wanting something and getting it. So the part maybe most people are missing is that intelligence as a trophy isn't just about being smarter, but it's about tightening a loop. If you think about you having an idea, then you express it, the system responds, you adjust, then the world changes. It seems like what Meta keeps doing is tightening the steps in that cycle. That's why features like Imagine matter, because images that change as you type, they create a less friction than a usual software. It's more like thinking. That's why the glasses matter, not because they're flashy, but because you don't have to reach for anything. The interface is just there. That's why transitions matter, translation matters, gesture input matters, and automated ads all fit that same pattern for what they're building. And none of it's going to arrive at some dramatic moment. It's going to arrive as convenience, and convenience is the power that they're trying to get to. The tighter the loop becomes, the more the interface is decided into what feels natural when you're interacting with the real world. And by the time you notice the cocoon, you're already inside of it. Greater delegation can feel like freedom. But when command friction drops far enough, the system doesn't just execute, it predicts, it preloads, it suggests, it shapes the space of available actions. And the boundary between helpful and steering become a design decision. And design decisions compound on themselves. All right, next up, let's talk about this research on internet gaming disorder. I got a feeling this is kind of like in the same direction as the same disorder AI is going to give for a lot of us. Talks about the mediating role of relative deprivation and moderating role of grit. So I kind of used to associate like the idea of getting rejected by your friends at school as what would cause somebody, especially a kid, to get addicted to games. But this is looking at why some rejected kids get addicted and others don't, and the surprising parts between the two. So the nuance to me felt important. Being rejected by peers does not directly cause gaming addiction, is what they found. The study followed over 1,000 kids for a year and found one hidden step in between. It's called relative deprivation, okay? Relative deprivation is the name for this step. It's not just the feeling of feeling left out. It's the feeling others have something that you should have and you've been unfairly denied it. Like, I deserve that. I should own that and I'm not getting it. Versus just not getting it. You know what I mean? So the pattern was pretty clear from the research. It followed, all these kids, thousands of kids, over 1,000 kids. And Peer rejection came first. That rejection created a feeling of deprivation months later, and that feeling led to internet gaming disorder. So rejection isn't the trigger. The belief that life is unfair is. But here comes the twist. Grit changes the outcome. Grit means sticking with long-term goals when things get hard. Kids with low grit turned deprivation into gaming addiction. Kids with high grit did not. Same rejection, same unfair feelings, different endings. So the real danger isn't being pushed out, it's believing the only place you still belong is inside of a game. And for me, there's a lesson. For maybe many of us, there's a lesson we're thinking about now. All right, let's talk about the real reason conversational AI gets so many things wrong and a new architecture that might fix it. So posted at VentureBeat, they say that the most conversational AI today sounds smart, but it gets the goal wrong. A customer types something like, I want to cancel, and then it has to make a decision like, do they want to cancel a service? Do they want to cancel an order or an appointment? Like, what are they supposed to do with that information? In what context? And that would be a system that's using RAG, right? It's got databases, it's got an embedded query, and it goes and looks something up, but the retrieval doesn't equal understanding. So if you train the model first to understand intent, you have to think about what the intent is before you go to the retrieval process. So that's what intent-first architectures do. It's essentially two models. I kind of feel like the human brain might work a little bit this way too, but it uses a lightweight model to classify what the user means before looking up information. So it's a totally separate model that's like, oh, that's probably what he means. Now go and like actually look up some information regarding, billing or FAQ or whatever activation step it is. The interpretation I'm getting from this is that I think there might be a future where something like your iPhone has a local model, and that model isn't even trained to solve problems. It's an intent model. And then it goes out and maybe like queries ChatGPT. If it's a more complex thing, it does a deep research. Or if it needs to go into your phone and like pull out some data, it makes that decision. But the model itself, the local model, isn't as smart as we're trying to make them right now or as powerful, but it's truly trained on human intent. All right, this next one is pretty wild. So we're talking full 10,000 foot view here. We have to really kind of think broadly to make this article make sense. It wasn't something that was intuitive to me, but the article's kind of about how traffic has the best information. Traffic is the smartest at making predictions about what's going to happen right before it falls apart. So there's this moment where you can think about traffic like something moving around a physical computer. So here's what's strange about this. Traffic doesn't compute best when roads are empty. And it doesn't compute best when everything is jammed together, when everybody's like stop and go traffic. But it does kind of work as a data source that can make a prediction right before congestion begins. So researchers treated traffic like a computer, not metaphorically, literally. Cars moving through intersections create patterns. Those patterns react, shift, and ripple. That motion can process information. The idea is called harvested reservoir computing, and it means using systems that already move instead of burning energy on energy-intensive chips. And they tested it with tiny self-driving cars and simulated city roads. And what they found surprised them. Free-flowing traffic is too simple, full congestion is too frozen, but medium traffic just before the jam is rich and alive with the ability to compute. Small changes spread through the system. That spread carries information enough to predict what traffic will do next, and it needs almost no extra energy. No new hardware, just sensors cities already have. Okay, so that's just crazy to me. Putting sensors around the city to see where cars are and then using that to compute. The takeaway is simple. The city is already thinking. You just have to catch it before it locks up. So the theory is you could eventually have like red lights and green lights timed different. You could make subtle changes to the city, like where the lines are. And what you're computing is what traffic will look like 30 seconds into the future, a minute into the future, an hour into the future. So the system itself, the entire city could ask itself a question, like if I change this one light in this one intersection right now, will congestion form soon or will I be able to avoid it? And the key idea is that the system can actually learn over time how to keep congestion from forming. All right, next up, let's look at how animals build a sense of direction. So for decades, scientists argued over one quiet question. Does the brain's compass, knowing which direction you're facing, stay fixed or does it reset as you move? So this is a pretty interesting question. Most people assume direction comes from big signals like the stars or the sun, Earth's magnetic field maybe even. But when 6 bats were released into a dark, unfamiliar island, none of that seemed to matter. Their internal compass didn't lock onto the sky, they didn't follow magnetism. Instead, it slowly anchored itself to the ground. So at first, bats' direction cells were sloppy, north-south, east-west, only roughly defined, but after a few nights something changed. Those same cells snapped into a precise direction and stayed that way everywhere on the island. Not piece by piece, not by region, one global compass built into their brain based on the ground and the map they built from it. The key detail is why. Is there something we can learn about AI getting grounded? Is there something we can learn about ourselves? And as the bats explored, landmarks did become reference points, like the coastlines, the tents, the perches. Their brain stitched local views into a single map, and then the compass aligned itself with that map. So this actually settled a long-standing debate. The brain doesn't carry multiple shifting compasses. It builds one, and it pins it down to the world you learn. So I think this applies to us as humans. The direction, that means like the direction isn't about where you are. It's about what your brain decides counts as the world. So neurons known as head direction cells are connected in a ring-like network that is always active, and the cells anchor themselves to landmarks. As the animal turns to face new directions, different cells are activated. And if that changed your life forever, you could thank this guy. Thanks, guy. If you made it this far and you want to support the channel, press that hype button on YouTube. If you go to the mobile, go down to the comments, swipe left. You should see a hype button there if the video is posted in the last 7 days and you have one or at least one of your 3 hypes for the week left. But hypes really matter for smaller channels like me. They give us disproportionate attention. Thanks for watching. I'm going to go put together a whole bunch more articles. Like there was a few that didn't even make this video because it got too long. So I'll probably put up another one really soon. We'll see you in a second, or see you in the next video.